I can see that the attendance list is growing. We're fast approaching 100 folks. Glad to have everyone here. Welcome to our latest edition of NSSA's Space Time. As I think most of you know, I'm Steve Jakes, the Executive Director of NSSA. We're just delighted to have you here. And wanted to give you a heads up to stay tuned for more of these Space Time series, as we're working up a pretty good active series of future sessions you just won't want to miss. So setting the stage briefly for our what I'll call post-Labor Day kickoff, we're delighted to have Dr. Derek Tournear as our honored guest. He's one of the hottest guys in town, as you all know, and to be hosted by our very own board chairman, Joe Dodd, who most of you know as well. You could call him Joe Dodd, Joe Dude, or just Dude, call him whatever you want, but he is our leader. Delighted to have you here running the show here today, Joe. And as most of you know, Joe's paying job is he leads corporate development over at Linquest. And so without any further ado, I'm happy to turn the mic over to our chairman, our head dude, my good friend, Joe Dodd. Over to you, Joe.
Great. Thanks a lot, Steve. And again, good afternoon, good morning, everyone. Welcome to NSSA Space Time. This is a recurring virtual platform that allows us as innovators and thinkers to speak on all things national security space. NSSA is committed to helping shape a vibrant national security space enterprise and to cultivate a network that fosters collaboration for the greater good of our nation, our allies, and other partners. We believe in supporting and advancing long-term cooperation with independent and trusted perspectives, expert opinion, insight-driven strategy, thought-provoking studies, and data-driven analytics. We're here to move the needle with our industry partners, government colleagues, colleges, universities, and the general public. These goals are made possible by the continued support of our corporate and individual members and the future support of many honored guests, many of whom are joining us here today. And speaking of honored guests, as Steve mentioned, I'd like to introduce Dr. Derek Tournear. As everyone here I'm sure knows, Derek is the director of the Space Development Agency within OSD's Undersecretary of Defense for Research and Engineering. And for the first 20 minutes or so, Derek will be providing an SDA overview and update, followed by a few questions that I'll pose, and then we're going to open the mic, the virtual mic, and enable the Zoom Q&A function so we can have a very dynamic conversation here with the audience. So Derek, thanks again for setting aside your valuable time joining us today. And without further delay, the floor is yours.
Well, thank you. And it's not myself that is the hottest ticket in town. I'm sure it's the fact that Space Development Agency is the hottest agency in town, and it is exciting times for SDA, and that's why we're up to such a fun start. And the reason that we're such a hot item right now is that we are doing things in space by hitting milestones and hitting commitments that we said we were, that people didn't think were possible. So just before we dive into this, I just want to point out, and I'll go into more details later, but we have just kicked off our Transport Tranche 0 contracts with two different vendors, firm fixed price. And to put this in perspective, so each one's delivering 10 satellites in under 2 years, which is unprecedented in itself. But when we first thought about how much this would cost, we assumed that it would be on the order of $16 million a satellite. And there were a lot of people in the department that pretty much laughed at us and said that we were crazy, and they didn't think that we knew what we were talking about. If you take the average of the satellites and the contracts and you just average everything, even including NRE, we put fixed price contracts out there for $14 million a satellite. So that's pretty impressive. So we're able to hit things, and we think this is a new future for space. And so that's what I'm going to talk about. I'll talk about how we're delivering capabilities, what that looks like, what are those capabilities, and what our plans are. So next slide, please. So one of the key things, if you go back and look at the 2018 National Defense Strategy, it's pretty interesting because it talks a lot about speed, whereas previous national defense strategies have always talked about great power competitions and how we needed new and better technology. The National Defense Strategy in 2018 did not say that. It said we have the best technology, but we're just horrendous at getting that to field rapidly. So we need to focus on that. And because of that whole model and making sure that we modernize in a very efficient, rapid manner, the Undersecretary of Defense for Research and Engineering was stood up. And that office has the goal of modernizing the department's ability to conduct warfare. And it has several different trust areas under that modernization priorities, one of which is space. And as part of that, the Space Development Agency fits right in with USDR&E because we are developing the next generation national defense space architecture that we think will disrupt the way the department currently does space. Next slide, please. So if you look at this, what came out of the National Defense Strategy subsequent to that was this DoD Space Vision, August of 2018. And it said there are these 8 capabilities that we want the Space Development Agency, well, it hadn't been established at that time, but essentially there are 8 capabilities we want the department to do in space. And then when the SDA was established, it said, we want you to go after those capabilities. And so if you look at this around this globe here, or all of the different capabilities, and it is everything we do in space. Well, we want to make sure that we have something that's actionable and we can actually build a program around and move forward. So the next slide talks about how we focus that down. And what we wanted to do is we wanted to start and end with the warfighter, right? So a lot of what you hear talked about with U.S. Space Command and U.S. Space Force is talking what we need to fight and win in space. You know, they're talking a lot about space control and those kind of activities. That is incredibly important, obviously. But Space Development Agency is actually taking a little different view at this problem. And we're saying, what does the actual battlefield that will happen on terra firma, what is needed to be able to make sure that we can win on the ground from the capabilities that we would provide in space? And so if you look at that, there's basically 2 capabilities that we plan on delivering. This is what we're focused on for our first set of capabilities. Number 1 is beyond line of sight targeting for time-sensitive ground and maritime targets. So what that means is I want to be able to detect, track, identify, form a fire control solution, and send those data down directly to a weapons platform for targets, think TELs or ships, things like that. I want to be able to do all of that from space without ever going to the ground. I only go to the ground when I'm going to a weapons platform. It's capability number 1. Capability number 2 is do the exact same mission, except now instead of doing it for time-sensitive ground and maritime targets, I want to be able to do it for advanced missiles, hypersonic glide vehicles, dim upper stages, cruise missiles, etc. Those kind of things. I want to be able to do the same mission, but now for missiles. So the next slide talks about, you know, how we will actually do that. What our architecture, this is the National Defense Space Architecture, what does it look like? So I use the icon on the right side of the slide here to talk through that. What I like to point out is this is a functional block diagram. People can think about this in different ways, but don't think about this necessarily as a set of different constellations, although it roughly represents that. But what it really is a set of functions that are part of our architecture. So the backbone function is in the gray-blue box. That's our transport. That's our data transport layer. That is hundreds of optically connected meshed satellites that will be able to communicate low latency comm amongst themselves, as well as be able to send data directly down to a weapons platform via existing tactical data links. Example, Link 16 is our first canonical example that we're going after. In addition to that, we'll also be able to send those data down to the battalion level commanders with the Army's Titan ground system, where we would be able to go down that with optical or KA, and then those data could be disseminated out from there. We're working with the Navy to do something similar, as well as the Air Force as part of their ABMS platform. That's the transport layer. That's the backbone of how all this ties together. Now, inside of transport, you see that blue nav box. Essentially, that's a freebie. So what does that mean? So if I have this optically connected mesh network of satellites that does very good timing transfer to be able to make that optical connection, that means that I can get a very good time and position data set on each of those individual satellites. So if someone is plugged into our network, that Link 16 network, I can send a navigation message to them that allows them to get an alternative timing and navigation message independent of GPS. At this time, we're not planning on broadcasting out a separate nav message like GPS, but we're providing a navigation message over communication networks that are tied into our transport layer. So that's the backbone. That's how all this ties together. Now, all that gives you low latency comm, which is great, but it really doesn't allow you to get to those two capabilities until you start adding data on that network. So that's what the sensing layers are to the right. The top one in orange is tracking. That's our OPIR system, tracking meaning missile tracking. So that allows us to do detection, tracking, and fire control data formation of any advanced missile systems detected via OPIR. Those data are sent and fused together onto the transport network. The transport then can send that down to Aegis or something else that could, in essence, take out that hypersonic glide vehicle. The next sensing layer down is custody in green. That is our ISR network. So this would be a constellation of satellites that we're relying on mission partners to build out. That could be optical, it could be RF, ELINT, or SAR, to be able to detect and track different targets, and then we would be able to send those data directly to our transport satellites. So those data could be fused, and then that fire control solution could be calculated and sent to a weapons platform. So these custody satellites will primarily be mission partner satellites. So that could be other partners in the DoD. It could also be commercial partners. You know, there are a lot of different commercial companies that are working on proliferating constellations of sensing satellites. We want to work with them to make sure that we can tie that into our transport network to be able to form a fire control solution. The third sensing layer is deterrence. Right now, we're just in the study phase on that, but essentially that is our space situational awareness layer. That is to look at the area in geosynchronous to cislunar space and be able to do detections and send those data back down to the ground, essentially to the NSDC, so that it could be promulgated out with the rest of our space surveillance network. That, in essence, is all of the sensing and data transport of our architecture. And then you'll notice this light blue battle management that goes across all of them. Battle management is really the magic that makes all this happen. So the more you pull the thread on what I said here, the more you realize that what I've described is an extremely difficult problem that sounds very magical. I'm going to be able to tip and cue multiple different sensors. I'm going to be able to move those data across an ad hoc mesh network, and I'm going to be able to actually form and fuse a fire control solution and get that to a weapons platform. There's a lot of magic that has to happen there, and that is the battle management layer. So the battle management layer is, in essence, a computational cloud in space that resides mostly on the transport layer, but it can reside on some of the other layers as well, where we actually do the smarts to be able to fuse the data. We will take machine learning based algorithms that we're all trained on the ground. We're not doing new algorithm development, especially not up in space, but we'll be able to fuse those data together, utilizing those algorithms on board in space, be able to tip and cue autonomously, and then be able to autonomously route fire control solutions to weapons platforms. So that's the overall goal. That is the vision of the National Defense Space Architecture and how we plan on getting it to work. And then obviously you need a support function that provides your launch, your command and control on the ground, as well as any specialized user equipment, which right now we don't anticipate, but there could be in the future. Next slide. So big question is, how does this fit in? How does the Space Development Agency fit in with the rest of the department? Well, this is, I really like to talk about this. And in order to really explain how it fits in, I have to explain my experience and my base that I'm bringing into this role, because a lot of that really shapes how we've set up the Space Development Agency and how it's operating within the department. So this is my second stint as a civilian in the government, and prior to this role, I was in industry for 7 years. The last role I had in industry was the Director of Research and Development for Harris Space and Intel. And in that role, it's a pretty good sized company, had a lot of different businesses, had the legacy Kodak imaging system group up in Rochester. So I was able to talk to those guys about, hey, you saw what happened with Kodak. You saw how it got supplanted. how did this happen? I got a lot of insight into that. I also saw a lot of the new innovation that was being done in the small satellite world down with the Palm Bay group down in Melbourne and developing things. And so I wanted to try to figure out how I could structure my research and development organization so that I could enable what was keeping the lights on, the large business and the large customers inside of our $2 billion business. But at the same time, I needed to make sure that I didn't get supplanted by some startup or some new technology. And I actually wanted to try to have some of those disruptions in-house. Very difficult problem. So I did a lot of research on that. And I actually came across this book that I fell in love with the ideas in it. It's the late, great Clayton Christensen's book, The Innovator's Dilemma. And in that book, he basically describes this exact same problem. And in it, he gives several examples, historical examples of how that has happened. And essentially what happens is the following. If you have a large entity, corporation, government entity, it doesn't really matter, that has one mainline customer or a set of customers that it answers to, it will develop the values inside of that company that ensure that they can give that customer exactly what it needs in a very low risk incremental approach. And because that's what they value, they're going to develop the resources and processes within the company to maximize around that concept. And it works quite well. And that's why companies grow, they make a lot of money, and it's an effective way to run a business. However, if you have entities that are smaller and they don't have an established mainline customer, then they have a different set of values. Their values are based on getting quick wins, being very rapid, and being very agile so that they can go after a lot of different customers with a lot of different concepts and try to make sure that they spiral out what actually works. And then historically, you can have three outcomes, right? So you can have the disruptor, the innovator just fails, the technology never takes hold. That happens. And you can have the second one, which is where they actually succeed very well and they grow extremely quickly, in which case the market eventually shifts to them, and it shifts so that there is a big disruption and the larger entities are kind of left in the lurch. And then of course the third one is you have that disruptor that's going extremely quickly and the big entity or big company sees it early on and buys it out and basically ends the disruption. But those are kind of the main outcomes. And so I instituted this within Harris Space and Intel, and the way I did it was I essentially got buy-in from the sector president that we were going to hide a portion of our IRAD budget, and we were going to call that innovation, and we were going to have an innovation director that invested that money with no accountability, essentially. So the accountability was every quarter they would come and say what they did, but they would never ask for permission. So she would invest in a lot of different things and never ask for permission before doing it, because she just knew what the vision of the company was, where we wanted to be in 10 to 15 years, and she would work towards that. So some of the examples that came out of that, one is shown here, NTS-3, that's Navigation Test Satellite 3. That is a completely new way to do position, navigation, and timing that would not have been invested in with our IRAD dollars, but innovation we could put forward. And now it is a Space Force Vanguard mission, is one of the new ways to do position, navigation, and timing going forward. Why wouldn't we have invested IRAD into that? Well, for one thing, it was competing with our GPS business. That's a big deal, right? That was a over $100 million a year business for us in Clifton, New Jersey. This was directly competing with us. Why invest in that? Second of all, I didn't know the customer very well. Would the customer actually buy something like this? The technology was unproven, just a lot of different what ifs. So if I were asked the question, do you want to invest in NTS-3, or do you want to take that money and invest in GPS-3, which is now for competition, and we know that if you invest in it, we have a much better return on investment that I can prove, which one am I going to go with? Obviously, I'll go with the incremental low-risk approach. That's the innovator's dilemma. So that's what's set up within the department. So inside the department, you have a Space and Missile Center, now Space Systems Command. That is the large entity. So they are the ones that need to give U.S. Space Command exactly what it needs to fight and win in space today and in the near future. And they need to do that in a low-risk incremental approach. We can't disrupt that because that's what we need today. Space Development Agency is the innovator, the disruptor. We're out there, we're valuing agility and speed over all else to make sure that we can develop a completely new architecture that fields new capabilities. What is this architecture based on? So I already kind of described the architecture, but it's based on two pillars. Pillar number one is proliferation. I believe that hundreds and hundreds of satellites is how we're going to enable this in the future. That's what gives us resiliency and advanced capabilities. And second pillar is spiral development. We're going to put these capabilities up every 2 years. We're not going to slip schedule to add requirements. We're going to have a minimum viable product that we're going to launch every 2 years. As new requirements come in, they will just get put in the next tranche of satellites and get rolled into the next set of capabilities. And that's the way Space Development Agency is developing a new architecture that we think will disrupt the way we currently do space in the department. Next slide, please. So that's how we fit in with Space and Missile Center, and we're a disruptor. But now there's still a lot of questions about how do we fit in with the other disruptors in the space community within the department. So we know Space RCO is already out there. Mike Roberts, good friend of mine who runs that. DARPA, AFRL, obviously we have a lot of these groups that are supposed to be disruptive in space. Here's the difference, and here's how we all fit together. So if you look at Space RCO, DARPA, and AFRL, they all do technology development. They're really focused on doing technology development. And where you start the development, the maturity level of when you start, says whether or not you start with something that's mature, starts with Space RCO, in the middle, DARPA, very nascent, starts with AFRL. But they do technology development. They demonstrate that technology has military utility. Space RCO takes it a little step further. A lot of times they will take that technology, demonstrate it as military utility, and operationalize that. But they do it kind of in that one-off setting. SDA is different. We're not doing technology development. In fact, I am trying to force us away from that, work with these other partners. We want to take technology that's at a high technical readiness level, like 7 to 9 in this chart here, and be able to take that technology and implement it in a new architecture, and then show that that architecture has military utility, not just the technology. That's what we're demonstrating. That's how we're different. Missile Defense Agency is a little different. They're a hybrid. They do technology development and architecture development, but they primarily look at interceptors, data dissemination, and radars, because that's the backbone of how we do the missile defense architecture. And so MDA has a small portion that does space, whereas SDA is kind of the opposite. That's all we focus on, is how we enable capabilities on the ground from space. And so we're all about space capabilities. So that's how we fit in with all of our brothers and sisters in the department. Next slide. So I talked a little bit about what tracking and custody we're doing. This is kind of more details, and this is especially appropriate when you're talking about MDA and how we fit in. So tracking is our OPIR system. In order to do all of that kill chain, detect, track, fire control formation, send it to a weapon system, we worked with MDA, and we essentially all came to the conclusion that we probably need 2 sets of satellites. One with a wide field of view sensor. This will allow you to do the full global coverage and the advanced missile tracking, but it may not be able to have the sensitivity to get the extremely dim targets. So when these targets, when they get dimmer after launch, you may lose them with the wide field of view system. Secondly, you may not have the quality of service actually needed to be able to fire on remote, like you would for Aegis, to be able to send it something that it can fire on remote without engaging its own radar system. So that's where the medium field of view system comes in, and that is the MDA HBTSS program. So HBTSS cannot give you global coverage, but what it can do is once it's cued from the wide field of view system, it can give you a very accurate fire control solution that you can use to fire on remote. In addition to that, it can also track targets that are dimmer than the wide field of view system, just because it has better sensitivity. So that's how these two fit together. So the wide field of view system will cue the medium field of view system, and both of them will send data to the transport layer, which can fuse the data and also then send the data to the ground to be put onto the C2BMC system or sent directly to a weapon system to take out and prosecute a target. And that's how tracking works in a nutshell. The next slide is custody, and the overview here, the key takeaway here is that you'll see again those proliferated constellations are gray. The reason they're gray is we expect mission partners to build those out. But we're working with them and providing them the package so that they can communicate directly with our transport satellites, so we could fuse data from multiple different constellation providers and then calculate the fire control solution and send it directly down to the ground to a weapon system. Next slide. So this is what we plan on delivering in over the next few years. So right now we're in our demonstration phase where we're teamed with DARPA, MDA, and AFRL to do a set of demonstration experiments over 2021. We're going to be doing those experiments in December of this year. We plan on launching 2 satellites that will do an optical crosslink demonstration. Satellite to satellite, satellite to the ground, and satellite to airborne platforms, all optically. We're working with AFRL on that, as well as DARPA. And then a little later in the year, we plan on flying another 2 satellite optical crosslink demonstration just from another vendor to show that there's multiple different commoditized optical crosslinks. In addition, we also have 2 sets of OPIR tracking satellites being developed. One is a medium field of view demonstration that Northrop Grumman is building for us, that's going to launch early in 2021. And then another one is a wide field of view system that's going to launch later in 2021 to be able to demonstrate that. Along the same time as that wide field of view system, there's going to be another set of 2 satellites that are being done as part of the DARPA Blackjack constellation to be able to demonstrate wide field of view OPIR from a different vendor to show that all that technology works. Now, while those demonstrations are going on, we're going to be building out our Tranche 0 satellites. And this is what I mentioned before. As part of that is our 20 Transport Tranche 0 satellites. So we'll have 20 satellites up there, optically connected, and being able to also communicate down via Link 16. That will be the nucleus of our Transport Layer mesh network to show that that works. All right. Now, along that same time, we're going to fly up to 8 wide field of view OPIR systems that's part of our tracking layer to show that we can detect, track, and send those data to the transport layer. Shortly after launching those wide field of view systems, MDA is going to launch the medium field of view, HBTSS, that will also be able to plug into our wide field of view systems as well as our transport systems. That will demonstrate the entire kill chain of the tracking system. Medium field of view, wide field of view, transport. Around that same time, our mission partners are going to be flying ISR satellites. They will not have the capability in Tranche 0 to talk directly to transport, but they will essentially talk to the ground and then right back up to transport as if they spoke directly. And then transport will send those data down to, we're going to work with the Army to send it down to their Titan system, the Navy to send it down via the Knife to some of their systems, and then as well as working with the Air Force to send it to their air platforms, in addition to directly to a weapons platform via Link 16. And then Tranche 1, now we're going to launch hundreds of transport satellites to be able to get persistent coverage over a given region, and dozens of tracking satellites to be able to get persistence over a given region and continue to work as our mission partners build out custody. And that's basically what we're doing in a nutshell. The next slide is just the capstone that goes through what we're going to demonstrate with Tranche 0, which I've already kind of spoken to. We're going to do that tracking demonstration, detect, track, send those data to transport satellites, which will then send the data directly in theater, and the same with the custody going through the ground directly to a weapons platform in theater. Next slide talks about the minimum viable product for our Tranche 0 and 1, which I went through in the Gantt chart essentially, but this gives it in a little finer point about what are the exact details of what we're doing in each tranche. And again, Tranche 0, think about that as our warfighter immersion tranche. That will give the warfighter enough capability so that they can see the utility of this new architecture and start to fold that into their ConOps, their O-plans, and their techniques, tactics, and procedures so that they can plan for this in the future. 2 years later, Tranche 1, that is when we give persistence over a given region. I don't use, for spiral development, I don't talk about initial operating capability and final operating capability, but essentially that would be initial operating capability, because that's enough capability to affect a fight, because now we could concentrate over a given theater and be able to provide persistence over that theater. And then the next slide goes out even further in time, and you'll see Tranche 2. The concept there is that's when we would get, if you will, FOC, right? So now we have full global persistence. We have hundreds more satellites up, giving us the full global coverage. And then Tranche 3 is when we start to fold all of the lessons learned from Tranche 0 and 1 back into the system, as well as transitioning new technology that's currently being developed, such as through the FNC Cubed program that's developing new ways to do protected SATCOM, as well as new different laser comms. That's when that would fold through. And again, every 2 years, just folding this technology. So we don't slip these tranches. We just put it on the next one as it becomes available. Next slide. So this is this is just to show that we have been extremely busy over the last year. So we've, as I mentioned, we awarded the contracts for Tranche 0 for transport. We're going to award for tracking Tranche 0 shortly. We're in source selection now. We're in source selection. We have a lot of source selections going on that I'll show on the next chart. But this one just shows that we've had a lot of awards essentially on the time scale of getting these demos up, focused on Tranche 0, not only the Tranche 0 hardware, but also then being able to put together the ground architecture and ground infrastructure for that, and be able to move forward and get everything done on time to hit that launch schedule. Next slide. I know this is recent news, which I've already mentioned. This is I can spend a half hour talking about this, because we're really proud of this baby. Where just to put this in perspective, let's talk about this acquisition, just so everybody realizes what I mean by we're trying to go quickly. In April 2nd, we were all scheduled to meet at the Space Symposium in Colorado, and we were going to have our industry day coincident with the Space Symposium. Obviously, then COVID hit, nobody traveled. We still held on April 2nd our industry day. We held it virtually, and May 2nd, so a month later, we actually released the RFP, or May 1st, we released the RFP, which was our original scheduled plan, and we awarded the contracts. We did a best and final, and then we did a down select and an award, and so we announced that award on September 1st. So we really pushed hard to go through that. There were a lot of proposals to go through. It was a very good solicitation. So we're pretty proud of that, and we're excited to see these satellites once they're under construction now with Lockheed and York. Next slide. So this is how you can work with SDA. So I already mentioned that transport Tranche 0 is on contract. Tracking is in source selection. Battle management is one of the key things to watch going forward. So battle management has a lot of different aspects. It has the mission-specific applications. So this would be the custody applications that would allow you to do the tipping queue and in data fusion. We're in source selection for that right now. We'll also probably have more solicitations for that as we learn over time. But then there's the backbone for battle management. How do you actually do a lot of the integration and get that system working at the system level versus just the application layer? And that solicitation should come out shortly. It'll either, depending on appropriations, is essentially for FY21 is essentially what's going to set the timeline for when we go out with that solicitation. Beyond that, we're starting to look at just around the corner our Tranche 1, hundreds of satellites. So we're going to have solicitations go out for that probably in late calendar year 21 to make sure that we can start to get Tranche 1 on contract and moving forward. Next slide. So more important than working, from my perspective, working with SDA is working for SDA. So we're growing. We're really looking for people to come with their ideas and come help us get started. So to give you an idea about what we're looking for here. So we are, I come with the industry experience. I'm looking for people that understand what is necessary to actually build satellites and get these architectures up at scale in a rapid time frame. We're not, we're not a traditional government acquisition organization where that's not the experience base that we're pulling from. So that's what we're looking for, people that can bring that experience base in, industrial experience base in, to kind of help with that and be able to if you want to come in and help launch a lot of satellites, build and launch a lot of satellites in an unprecedented amount of time, SDA is a good option for that. So please go to our website, sda.mil, and you'll be able to see different opportunities there, and you can send us your resume at this email address that's on the screen. And that's it. So I'm more than happy to take any questions, and hopefully I was able to answer some already.
Great, Derek. Hey, thanks so much. I think you packed about 3 hours of content into a half hour of time, so that genuinely was amazing. And so we'll transition now to the Q&A and discussion. And we've got a number of them pre-staged here, so let me just launch right in. You've already mentioned one of your major milestones already passed in awarding the Transport Layer contracts just a couple weeks ago. And I know to many in industry, the awardees appear to be at both ends of the spectrum, an established Tier 1 prime, Lockheed, and then York Space Systems. What, if any, message might industry take from these award announcements beyond what you've already commented on in your overview?
I know, isn't that great? We got the bookends there, but I will say that, you know, the solicitation was done on technical merit, and then price was factored in after that. So honestly, the way it worked out was not preconceived, and the fact that Lockheed was a big aerospace and defense prime, and York was a small new space company, actually didn't fit in as well either. They both came in 1 and 2 on their merits. And it just worked out that way. I was actually very surprised. You know, I expected to see a wide range of proposals, and we did. I was actually surprised to see that actually the top 2 came in very closely ranked with good benefits and risks, and so we went with them primarily looking at which one gave us the most confidence, which 2 would give us the most confidence that we could hit the schedule. The other thing we did look at, and we're really excited with the breadth of the subcontractors that were pulled in. But one of the things that I've harped on from the very beginning is that I want to ensure that this architecture does not get vendor locked, right? So we put in a lot of different kind of catches that hopefully will prevent that with some engineering tools. One is we're going with 2 vendors. We're going to make sure that they go to the Naval Research Laboratory, where we're building out this hardware in the loop, software in the loop test bed with their engineering unit for their comm system, for their optical comm system, to make sure that they can plug into what is the government gold standard that we're defining at this NRL test bed. So that will show that not only can they talk to the optical links, but they can also match the back end for the networking layer. That's the best way I could say that's how we're going to force interoperability and prevent us from getting vendor lock, because that's something that I wanted to make sure that as we compete these tranches for the, you know, in perpetuity, there's not one vendor that has an edge and can lock out everyone else. In addition to that, you know, just the breadth of the different subcontractors that these 2 teams brought on with their optical crosslink providers and a lot of the other different bus providers. There's a lot of the Tier 2 providers that kind of cover the base. So we have a lot of the industrial base that's covered. So we're not just because we have 2 primes, we're not locked into one optical comm link. You know, we've got a broad base.
Fantastic, great, thanks for that. You've talked a lot about getting a lot done, moving fast. What's the recipe for getting so much done so quickly? Is the government team yet right-sized? And how do you manage a proliferated team where, as I understand it, you now have a lot of folks on the literal and virtual government team who are dispersed around the country? I presume many of them have joined the team recently, probably haven't even met in person yet. How do you make that work?
So that's a good question. So I'll start with how can we go faster than others? And this is an interesting aspect, because you'll hear a lot of people in the government talk a lot about what processes and things need to be changed to go faster. OTAs are often mentioned, and the reason OTAs are mentioned are because they allow you to essentially bypass a lot of the FAR restrictions. But I'll say I don't see it that way. So if you look at the FAR, our transport satellites were procured under FAR and their regular FAR contracts. The FAR actually gives you a lot of leeway to go extremely fast. And it all comes down again to the values. So SDA goes fast because we value speed. And because of that, we put the processes in place to make sure that is what we are focusing on, and that's what we're moving out on. It's only when you start to value more of the low risk approach that you start to fold that all the way back through your processes, and you start to add processes on top of processes, that you're not really constrained to do. And I think that's what actually causes the delays. In addition to that, Space Development Agency, you know, we are a separate agency. And because of the fact that we are separate, reporting directly to an undersecretary, I'm SDA's milestone decision authority. I am the source selection authority. We can move quickly. We can make decisions. We can move fast. We don't have to go through several layers of bureaucracy to do that. We have the authority and the autonomy to move extremely quickly. That was given to us precisely for that reason when we were established. So that, I will say, that aspect allows us to move extremely quickly. So it's not the law, it's not what's in FAR, but it is definitely what's in the processes because we were given the authority to move forward. Now, as far as managing a geographically distributed group, that is a challenge. I will say that my experience in industry, I think, gave me some tools and some mindset to be able to do that. Because when I was in industry, look, I was in Herndon. I had a handful of people in my group in Herndon. The majority of my team was in Florida, and then the second largest group was in Rochester, New York, and then I had some members of the team in Fort Wayne. So we just thrived on being able to do things via Skype, sharing screens, a lot of those different activities, and you kind of get used to those tools. So I think I was fairly well trained coming in to be able to jump into that mindset. And like I said, since we're actually hiring, so we have hired a lot of people in the Florida area that came actually from OneWeb. So they were already used to this kind of model, because I think industry has been doing that a lot more prolifically and efficiently than the government has. So that we've had a lot of people that already came in with that mindset and that skill set. So that helped. Otherwise, it's, you know, it's just the new normal, where we're used to getting on the phone and chatting with folks. One of the good things about Space Development Agency is almost everything we do is unclassified, so we can actually use a lot of the tools, such as webcams and such, that you're encumbered and you just can't do as easily in the classified world. But we've been able to move fast and keep it all in order.
Fantastic. You're about to hire an SE&I to help perform the systems engineering and integration for Tranche 0. What are the proficiencies that you're looking for there? Will the team be a little bit behind because you will have already made the 2 Tranche 0 awards? You know, how do you think about digital engineering as a tool kit or set that you'll want that team to bring forward to help you to go fast and to be efficient? Whatever insights you might give us in the theory behind having an SE&I contract would be of interest.
Sure, Joe. So I'm going to be careful here because we're still in source selection for our mission systems engineering and integration role. So I don't want to say too much about that question about what we'd really look for there. I'd say we will look for the qualities that are listed in the RFP, and that's all I'll say on that. But what I will say is, you're right. The satellite vendors are already chosen. We've already got Tranche 0 ground chosen. That's NRL. They're going to actually fly the satellites for us. So a lot of this has already been done. Those are all fixed price contracts. The SE&I is cost plus, and they're coming in essentially going to be helping as we do this integration. So I spoke a lot about, you know, how we were going to get tracking and transport to talk to each other using a common ground and this common interface. Well, that's no small task to make sure that there's a managed giver receiver list, so that what transport provider needs and is providing is known, and that handshake is done with tracking in the ground. And that's what the SE&I is going to do. They're going to come in and they're going to make sure that they have the capabilities and the teams that know enough to be able to make those handshakes and be able to track that kind of processes. And they'll be kind of the catch-all for the program management team, for the Tranche 0 overall program management team, to make sure the pieces fit together. As far as timing, would it have been better to have those on at the same time? Perhaps, but if I look at, it's the same model that the DARPA Blackjack program is using. They had their, they awarded, they were a little different because they awarded their bus and their payload independent. And then after they had those on contract, then they went out later for an SE&I role, and then they awarded a separate contractor to be able to do that, and they did that after the fact, and it's working out fine for them. And honestly, I don't think that the timing is that far off. They'll be on contract. They'll be on contract before SRR, so everything should work out okay.
You mentioned a lot about what you've already accomplished, the aggressive timeline you're on, everything that you just laid out in the overview over the next few years. It's just astonishing to see everything you hope to accomplish there. One of the tools that you've used in your acquisition strategy and your interaction with industry is oral presentations, and that's somewhat atypical in government. Can you comment on why your team thinks having that direct interaction with your offers and hitting them hard with test questions and scenarios, or otherwise having human interaction is an important ingredient in choosing the partners you want to work with?
So there are a lot of there are a lot of different ways that you can portray your plans and your concepts on paper that can either betray what you really plan on doing, or you can be betrayed by them and not be able to fully get across your understanding of the problem. And that's where I think orals come in. So clearly what's written on the paper and what's submitted in a proposal is what people can use and say, okay, this is what's held up. But if you have questions, if you have really real tough questions about, well, what about in this situation? How do you anticipate? I could answer on paper how I anticipate to keep a giver-receiver list, but I can't go through a set of 50 different scenarios on where there'll be exceptions to that giver-receiver list in a written proposal. But when you start to have that discussion with someone, then you can start to really understand, do you have the experience base because you have seen these kind of problems in the past, what problems may arise. That kind of comes through a little better in orals. And that's what we're hoping to get to. It's one of the lessons learned as we go forward in our future tranches. I think we will actually want to incorporate more orals in solicitations, because I think it does give a sense that people can then communicate their plans with a little bit more depth than what they're able to do in the written word in the constraints that we're giving them.
Thank you. One thing you're obviously doing, and this has been a priority from day one that the agency has been articulating consistently, and that is leveraging, not just leveraging, but using the innovation in commercial satellite constellations that cross the full mission set, not just traditional, geo milsatcom, which is well established, but the real innovators that are funded by VCs, and many of which will fail, but some are just creating new capabilities and technologies. When you think about constellations that are extraordinarily well funded, will have wherewithal like Starlink and OneWeb, how do you plan to leverage the production efficiencies or other innovations and benefits that they're trailblazing for your program?
Sure. So there's actually been there was actually some confusion early on when the Space Development Agency was stood up, and a lot of people thought that the Space Development Agency was stood up just to be able to plug into and use the commercial networks as part of a DoD network. But realistically, that doesn't hold very well when you're talking about you want to have a low latency network that you're relying on for tactical targeting and that kind of situation. It's just that's not what the commercial industry is set up for. So what we've always tried to communicate is that our goal is to leverage to draft behind what the commercial industries are doing within the industrial base. So if you look at that, that's what we're drafting on. So if I look at especially what OneWeb had a very good, it's part of their facility, they had a very good flow set up. They did an extremely good job of making sure that there was a supply chain set up that was supporting the industrial base. Well, that industrial base now is kind of out there and growing, and other people have been utilizing that. Starlink's a little more vertically integrated, right? So they're not as spread out, but some of the others are. And so there's been an entire industry base that has risen up and essentially commoditized most of the buses, electronics, solar panels, attitude control determination, and things like that. That is really what we're leveraging. We're leveraging that increase in the industrial base. So mostly the tier 2, tier 3 providers, so that people can leverage what has been commoditized, and we're going to take that commoditized components and place those onto a government-owned and operated infrastructure. So that's how we're planning on leveraging it.
Yeah, excellent. Thank you. You've spoken a great deal about the partnerships that you have and the broad community of stakeholders in various organizations. Can you expand on that a little bit and perhaps address your working relationship, either at the system, the technology, at the architectural level, with people like Colonel Russ Tehan, the portfolio architect at Space Systems Command, Mike Dickey in the headquarters, Andrew Cox, Sean Barnes, et cetera. And again, whether you might choose to address that at the system level, the mission level, the capabilities, the architectural level, whatever angle of attack you would choose.
Sure. So most of those relationships are all at the architectural level. So I'll talk about, and it's funny because within the department we've gone around a lot on what an architecture actually means. And I'll give Will Roper, he's great. I give him a lot of credit on this. He says, when we discuss this, let's not use the term architecture, because if you use the term architecture, that means too many things to too many people. So say exactly what you're talking about and what you mean when you say you're the architect of this, that. Don't use architect, talk about what you're doing. So in essence, if you look at Mike Dickey and Russ Tehan in their role, they are the U.S. Space Force architects, right? And so what does that mean? So what that means is they are coming up with what should the overall approach be towards developing these space capabilities of the future. Now keep in mind, back to that innovator's dilemma chart, they are on the top curve, where we're on the bottom curve. So what they are doing is they are looking at what is necessary to be able to develop technologies that will give us that low risk incremental approach, that will give us the solutions that we need, that we can sign up to say we guarantee we're going to deliver this. And so I'm working very closely with them, so I know their time frames of when they're doing what and how these pieces fit together. And they're working with me because I'm on that bottom curve, the disruptor curve. And the whole idea is that if when we're successful on getting these satellites all fielded and disrupting that current way, then there'll be this changeover. So in essence, I'm working with them to make sure that there are hooks in place so that there could be that changeover. But what we don't want to do is it's like on the monkey bars. You're not letting go of one rung before you've fully grabbed onto the other. And so because of that, that's why we're working together, and they're doing their low risk incremental approach. We're taking this disruptive approach on the bottom, but we are working extremely closely to make sure that we're not doing anything that is duplicative. So if they're doing something disruptive in proliferation, that would be better served under us, and we're not doing anything incremental because that would be better served under them. And we understand the time frames. So they have gates in some of their programs to where we won't go forward with this if you're successful on your tranche 0 and tranche 1, because then at that point the disruption will have happened. So we have those kind of discussions. Now on the technology side, the partners there primarily are working with, we're working with MDA also on when you're talking about the overall future of OPIR and missile tracking. They're involved just like Mike Dickey and company. So they're, Mike Dickey, myself, and Rich Ritter at MDA all kind of got together and over the summer came up with what the vision of the OPIR architecture would be. So with Mike Roberts at Space RCO, he's involved in some of the architecture level, but he's primarily, we're tying with him on the technical side to make sure that our programs are technically compatible so that we can work with each other moving forward. So that's how we're kind of tied in with that aspect of the community, as well as that's how we're tied in with AFRL and DARPA. So AFRL, we're actually relying on them to provide the Link 16 technology demo and burn down that risk. That's their XBI program. So we're tied with them technically. On DARPA, most of what we're relying on DARPA for is in tranche 1, because you never want to put DARPA on your critical path. Nothing disparaging against DARPA, but that's what they're for. They should never be on a program's critical path. But we're in essence going to transition all of that technology they're developing on Pit Boss and Blackjack into what would be our Tranche 1 battle management. So that's kind of how all of our brothers and sisters in the department fit together.
Derek, to a more specific question, perpetually, at least meaning the last decade or two, the future of OPIR has always been very important to the country, and been a lot of different opinions and views and passion as to what that should look like. Many of us had heard and read about a joint study that was to occur between Space Force, SDA, MDA, OSD about the eventual OPIR architecture, LEO, MEO, HEO, et cetera. Has that been settled? Can you give us an update on that?
Yes, it has been settled. We have a path forward. We actually have a report to Congress that was requested that is in coordination. I don't want to get ahead of that report to Congress, so I won't comment on it other than the fact that we worked on it, and we came up with a good plan. Plan's been bought off on by high levels within the department, and that's been codified in this report to Congress that's being coordinated now.
Yeah, great, thanks. I knew this was going to happen. My clock shows we have like 3 minutes left, and of course there's a cascade of questions coming in now from the audience that could probably fill up another hour, and we're going to be good stewards of your time and ours, and not run over here. So let me end with a softball, although there's one or two behind this if this is a quick answer. And as you might imagine, when I say softball, it may be something other than a softball. People are very interested in SDA as an entity, and when and if, when I suppose you'll be a part of Space Force. So what are the pros and cons of being absorbed too quickly, or not being placed or integrated in the right manner over the longer term? What are your, I realize there are a lot of voices, and there are very senior people in the Pentagon and folks with 4 stars, et cetera, who have all kinds of views, but I'm sure the audience would be very interested in your perspective on this.
Sure. So you go back to that innovator's dilemma, and there's no pros to being integrated in too quickly, right? The only pro would be if we weren't working well with the folks in the Space Force now, and that you were just trying to fix that, which isn't the case. We have a very good working relationship at all levels. So there's no pros. What you want to make sure is you want to make sure that you choose a time that is after you have demonstrated the new architecture, and it has got enough buy-in that disruption will take place. Again, go back to what happened at Harris. I would have never invested in anything had I been asked to do the return on investment. So if we got integrated into the Space Force too early, no fault on the Space Force, that's just the nature of where you sit. You're going to, because that's what you need to do, you're going to make investments that are more near term, because that's where you see the return on investment. So there's no way that you're going to prioritize something that is disrupting what you're working on if what you're working on has near term needs. So that's why we're looking, the department's position is FY23. We plan on having Tranche 0 up and operational then. And I think that's kind of the right time frame once we demonstrate the capability, and then where we fit into the Space Force. Again, we're still going to be a disruptor, so we have to fit in somewhere within the Space Force to where we do not we have enough high level crossover to where that determination between what gets where I draw the line between innovation and our traditional R&D or the traditional acquisition gets done at kind of the high level. That's in the NDAA, they wanted that to be done by that Assistant Secretary of the Air Force. It essentially said Space RCO, SMC, and SDA are all co-equal, reporting to the Assistant Secretary of the Air Force, who will then make that adjudication.
Yeah, great. Well, it turns out you left us with 20 seconds, so I'll wedge one in. Mike Griffin was clearly a champion and advocate, in many ways, the catalyst for SDA. Mike's no longer in government. Who is your champion today? Do you need one? Will the success on your programs, your acquisitions, the capability you demonstrate become your champion? What are your thoughts on that?
So absolutely, our success, our champion. So Michael Kratsios is a champion who's in the acting R&E role now. He's a fan. He's behind everything we're doing. The acting deputy is a champion, as is the secretary. So Secretary Esper is on the record. There's a quote in my charts about how SDA is kind of the innovation arm and pushing forward. That's why SDA was created. He's given us authority to essentially be the integrator for JADC2 in space for the department. So he's a champion, and we have champions throughout the government as we continue to hit our milestones and deliver. We'll just win more is the plan.
Well, Derek, our time's, the witching hours has already passed. So I want to thank the audience for their questions. Certainly want to thank you for your time and your energy, your passion, and being so transparent with us. I think that transparency helps everyone in terms of the ultimate outcomes here. Thanks again to our members for joining us today. Those of you who are guests and are not yet members, or your companies have not yet joined, I will shamelessly note that you can go to the NSSA website, nssaspace.org. Follow us on LinkedIn or on Twitter. And as we mentioned up front, this is the Space Time series. Very happy to announce this was settled, believe it or not, right in the middle of this webinar, that our next one will be at 11 a.m. on September 22nd with Kevin O'Connell. Many of you know Kevin. He's the director of the Office of Space Commerce in the Department of Commerce. So Derek, thank you very much again. Thanks to everyone, and everyone enjoy the rest of the day.
Thank you.
Thank you, sir.
Thank you, Eric.